Hello guys, welcome back to the software testing tips and tricks channel. So in this video we will talk about F1 score. So what is F1 score and how to calculate it? So in last video we have talked about how to test AI applications. So in that video we will talk about different parameters that required to measure the if how good AI application is, right? So when you are testing AI application, you should have some parameters. One parameter we can say accuracy. Other parameter is this F1 score. So if you know how to calculate F1 score for any applications, it will be beneficial while you are testing the AI, and it will give you the result of how good your product is. So let's start. So in this video we will talk about what is F1 score and how to calculate it. So F1 score requires different types of parameters. So I will talk about that parameters, how to get that parameter, and I will go through the formula, little bit of maths, and after that I will talk in the Python program how to run that and how to calculate it. So I will show that. So please watch this video till the end, and if you have any doubt, feel free to ask in the comment sections, and please subscribe this channel and share it to your friends, that will support me. So thank you. So what is F1 score? So F1 score is like harmonic mean of precious and recall. So if you know from the maths what is harmonic mean, the formula is very simple: 2ab into a divided by a plus b. So it is defined as same thing, like 2 into precision into recall divided by precision plus recall. So what does that mean? We need to learn that precision and recall. If we know how to calculate precision and recall, then it is very easy to calculate the F1 score, right? So F1 score always ranges between 0 and 1. 0 means very bad F1 score, and 1 is best F1 score. 0 means like your model is not able to predict anything, right? Anything positive. So this is what that means. And 1 means it has predicted all the instances correctly. Now, how to calculate precision? So, precision measures how many of the predicted positive instances are actually correct. So, whatever we have predicted, that is correct or not, that is what depends on, precision is dependent on that. So, their formula is TP into divided by true positive plus false positive. And high precision means fewer false positive. So, we need to learn again this: what is true positive, what is false positive, and how to calculate it. So, if you go through the recall formula, so recall measures how many of the actual positive instances were correctly defined. It looks same, right? If you go through the definition, it looks same, but it is not same. Like if you see the formula, recall equal to true positive divided by true positive plus false negative, and high recalls means fewer false negative. So what is false negative, what is true negative, and what is different between these two? So in precision, if you see, this is same formula, only this false positive part is there, and here like in recall, only false negative part is there. So now what is this true positive, false negative? Let's go through that to with the real life example to understand it very easily. So this true positive means the number of instances correctly predicted as positive. Example, the model correctly identified spam email as a spam. So I have defined like I expected result is spam, and model also gave their result as spam, so that means it is a true positive. Now what is false positive? The number of instances incorrectly predicted as positive. So this is not correctly predicted as positive. So legitimate emails wrongly classified as spam. So I have predicted this is not spam, but my model comes and say it is a spam. So this is called positive, false positive. Now what is false negative? The number of instances incorrectly predicted as negative. So example, spam emails wrongly classified as legitimate. So I have told like this is a spam email. I expected result, I put it as spam, but my model gives this is not spam, this is legitimate. So this is what called false negative. And what is true negative? The number of instances correctly predicted as negative. So legitimate emails are correctly identified as legitimate. So I told like expected as legitimate, and and model also give legitimate. But this true negative is not used in any of the formula, because like if you don't use AI only, by default all the emails are legitimate only, right? So there is no point to using that. So that's why true negative is not used. So if you see, this is binary classification problem. If we say like spam is 1, expected spam is 1, and If model has predicted, then it is 1, and expected legitimate is 0, and model has expected is 0, then it is 0. So 0 1 1 1 1 0 1 0 0. So all 4 combinations are there, and it is called this one. So to understand more easily, let's go through this. So whenever you see this, it is called confusion matrix, and it will solve your confusion now. So what that does mean? So true positive means this is actual positive and predicted also positive. I told like spam. Model also says okay, it is spam, and this is correct. Then that means this true positive is 1 1, and this predicted is negative. So actual positive uh, and predicted negative. So we said like it is spam, but model failed to identify that, and they tell it is not spam. So it is false negative. So this is how this metric is there. Now let's go through results and how to calculate this true positive, false positive, and false negative. So this is the very important, and concentrate here. So this is the I have instances, 5 instances. So I got 5 emails. First email I have ported expected result as positive, and also this my model also said it is positive. So those are got match. I told it is spam. You model also told it is spam. Second one I told like it is spam, but my model say no, it is not spam. Then I tell okay, this is not spam. Third email, model can no, this is spam. And fourth one it says like this is I have put it expected not spam, and he also said not spam. So both are legitimate. And in positive ones, for fifth one again I told it spam, and model also say yes it is spam. So we both agreed here. So this is the 5 instances result I have put. Now how to calculate this? So if the we see like what are the true positive? True positive means actual positive and predicted positive, both should be positive. So here in first case and fifth case, where we are saying both as positive, so my true positives are 2. Now false positive, so false positive is I told like this is not spam, but it falsely came, and the model came and said this is a spam. So this is 0 1. So 0 1 means here, and this is called false negative, and I have one false negative. False positive. I have one false positive, so it is here like 1 0 1. So it is here, and this one false negative. That means I told like this is a spam, and model says this is not spam, so instance 2 is false negative. So this is how you understand. Now you when you know like your true positive, false positive, and false negative, you just need to apply it into these formulas, right? These formulas you need to apply it, so you will get precision and recall. And once you get precision and recall, it is very easy to calculate the F1 score. Now let's go through the program. So before that, what is harmonic mean? So the harmonic mean is used in the F1 score because it gives more weight to the smaller values of precious and recall. This ensures that both metrics are taken into account equally. So for example, if precision is high but recall is low, the F1 score will be closer to the lower value, encouraging the balance. Let's understand this. So here like if you know the formula of precision and recall, we have in denominator this false negative, right? And in precision it is false positive. So if we see if we have more false positive and less false negative, then also like it will try to balance it, and it will give equal weighted to both. So it will give more weighted to true positive and equal weighted to recall false negative and false positive. So let's understand this using the program. So let's run the code. So I have this code, sample code, and I have put it this what is y true and prediction and ground truth. So ground truth is like what I have expected, and y is like what we have got predicted labels, and this is what we got from the this y true is we got from the model, and y predicted is what I have put it in expected list. And then after that I have computed this confusion matrix. This is Python code, and you can directly create confusion matrix with this library. And after confusion matrix is created, I am calculating true positive, false negative, and true negative. So whatever the instance is there, number of instances, we directly need to calculate that. So we are calculating this. After that we are putting this formula for f1. This is I calculating manually, this is from the library, and printing that. So this is like really easy. Now when I run that, what I got is I have two positives, that what we have in the slide as well, right? One and this one. So these two positive. False positive is 1, false negative is 1. We have 1 0 1 and 0 1 1, and 0 0 is like we are not counting at all. So what we got is precision 0.67, recall 0.67, and f1 score is also 0.67. So see, it gives equal weighted to precision and recall, that got proven. Now what if we change this, right? So for example, I got one more precision, right? And I put it 0. So now we don't have any recall, only precision here, and I have running this. So see, my precision become 1 now, and recall becomes 0.50, but my f1 score doesn't get changed. Why? Because like it gives equal balance. If you see, I changed that, but currently till now also, if you see, model did two mistakes only from five predictions. It did two mistakes. So this is become equal. But if I put is legitimate, right? So this is now also legitimate. So now if you see, my model did only one mistake, and now if I run this, so my f1 score got improved, because from 5 instances only one time it got failed. So this score got improved. And if we see like for all the instances it gives the correct result, right? Then it is 1. So this is the perfect example that you can see how precision and recall are given equal weightage in f1 score, and how much useful f1 score is to test the AI model. And so what is your aim? So when you are testing, you calculate f1 score become 0.60. Now you are improving your model, and again you are testing, and it is now 65. That means you have improved something. So this all is whatever we talk is for binary classification problem, right? So what about multi-class cases? So for multi-class classification, you calculate this true positive, and false negative for each class separately by treating one class as positive and the other class as negative. This process is called one versus all approach. So I will try to get this and create new video on this, but this is how it is calculated. So the now our confusion matrix will be larger, because we have three classes, so 3 by 3, 4 classes and 4 by 4, and you can sum values accordingly for each class. So this I will not include in this video, so we can learn this separately. So when to use the f1 score, this is some perfect way to know. So use the f1 score when the data set is imbalanced. So whenever data set is imbalanced, so what happens is your model will fail more time. So sometimes your precision is high, sometimes your recall is high. So for example, fraud detection, right? So for those kind of imbalanced data, this is f1 score is very useful, because both false positive and false negative has significant consequences. So whenever your model is failing, in f1 score we are giving both equal weightage, right? But if it is a solomatic and balanced data set, where you understanding the trade-off between precision and recall is not critical, either it pass or fail, right? Those kind of data set, what you can do is you can try using accuracy only. So this is when you should use f1 score. So yeah, that's it from this video. Thank you guys. Please subscribe this channel and share it to your QA friends. Like this video and comment your feedbacks or doubts in the video comments. And please follow our social media pages. Links are in the description. Thank you.